Hi, my name is Oktay. Welcome to today's video about the chemical element beryllium. This picture shows you a beryllium sphere. Beryllium has atomic number 4. Its name comes from the Greek word beryllos, which means mineral barrel. It is a tiny atom. It has electron configuration 1s2 and 2s2. In nature, there are 3 isotopes. The main isotope is beryllium 9 with 100%, and there are traces of the 2 radioactive isotopes, 7 and 10. On Earth, there is no more beryllium 8 isotope, but this isotope is very important for the nucleosynthesis of all the elements heavier than beryllium. This is a picture of the periodic table. Beryllium is here in the second group. It's a member of the alkaline earth metal group, and its origin is from cosmic ray fission. Beryllium is highly toxic and carcinogen. The human body contains about 35 milligrams of beryllium, and this 35 milligrams, the human body can handle that. This is a picture of the abundance of the chemical elements in Earth's crust. Beryllium is here. So it is low abundant compared to other light elements. But still, there's 2.8 milligrams beryllium per kilogram Earth. This is a nice picture of the nucleosynthesis of the lighter chemical elements. At the top left, that's the proton-proton chain that makes helium-4 of 4 protons. At the top right, there's another mechanism, that's the CNO cycle, that also merges 4 protons to helium-4 after one cycle. And at the bottom, that's the helium burning, called triple alpha process. 2 helium-4 merge to beryllium-8, one which merged with another helium-4 isotope. And then you get carbon-12. But there is a problem, and one of the problems is the low half-life of beryllium-8. It's just 8 times 10 to the minus 17 seconds. And after the Big Bang, the temperature of the universe dropped very quickly. So the nucleosynthesis was only possible 10 seconds to 20 minutes after the Big Bang. So the combination of this short time period of the low half-life and of the low concentration of beryllium-8, that made it almost impossible to synthesize other elements than hydrogen, helium, and lithium. That's why after the Big Bang there was basically only hydrogen, helium, and lithium. And this phenomenon is called Beryllium Barrier. The Beryllium Barrier prevented the nucleosynthesis of the elements heavier than lithium after the Big Bang, because there was just not enough time. And dying stars, however, the situation is different. Now you have enough time, but still the Beryllium Barrier is difficult to overcome. One beryllium-8 isotope can merge with helium-4. You get carbon-12 in a Hoyle state. And this is another bottleneck situation, because almost all of the carbon-12 isotopes in Hoyle state decay back to helium-4, 3 helium-4 isotopes. Only one in 2421 nuclides goes through internal conversion process, which gives you carbon-12 in ground state. And now you can continue the nucleosynthesis, one more helium-4 that gives you oxygen, then you get neon, magnesium, etc. And in a dying star, the core temperature has to be above 100 million Kelvin for this process to start. For comparison, the core temperature of the Sun today is at 15 million Kelvin. The isotope beryllium-10 is also very interesting. It is a product of cosmic ray spallation in the atmosphere. Its half-life is 1.4 million years. It is transported via rain into the soil, And this isotope makes it possible to examine the soil processes, for example, erosion and the formation of soil. At the bottom, these are the chemical reactions. Nitrogen-14 is hit by a neutron. It decays to a proton and helium-4 isotope and beryllium-10. Beryllium-10 decays to boron-10, which is stable, and you get a beta minus particle that's a fast electron. The nuclides 11 and 14 beryllium are also very interesting. They're special because of their nuclear halo. Beryllium 11 has one halo neutron, and the beryllium 14 isotope has 4 halo neutrons. These halo neutrons orbit the nucleus, and they give these isotopes a large radius of the nucleus. These are 4 beryllium minerals. At the left, that's beryl, which is a beryllium aluminium silicate. In the middle, that's bertrandite, which is beryllium silicate or hydroxide. Top right, that's bromellite, which is beryllium oxide. And the bottom right, that's chrysoberyl, which is beryllium aluminium oxide. These are variants of beryl, beryllium aluminium silicate. At the left, that's golden beryl from Brazil. Its color comes from the iron 3 ion. In the middle, that's morganite from Brazil again. Its light reddish color comes from magnesium 2 ion. And at the right, that's red beryl from Utah. Its color is from the magnesium 3 ion. This is another variant of beryl, that's aquamarine. It can be greenish or blue, and its color comes from the iron 2 plus. This aquamarine is a gemstone. Louis-Nicolas Vauquelin isolated beryllium oxide first time in 1797 when he worked on emerald and beryl. He made a test by tasting it. That's not good because it's very toxic. Beryllium compounds are very toxic. And because of its sweet taste, it gave beryllium its name glucine. Friedrich Böhler at the left and Antoine Bussy at the right isolated beryllium first time in 1828 by a reaction of beryllium chloride with potassium. That makes potassium chloride and beryllium metal. And the name beryllium was given from Friedrich Böhler. This is how beryllium is made today by reduction of beryllium fluoride with magnesium. That makes beryllium and magnesium fluoride. The world production in 2021 was 260 metric tons. Number 1 producer was USA, number 2 China, number 3 Uganda. This is a picture of a beryllium sphere. Beryllium has special properties. One advantage is its low density of just 1.85 grams per cubic centimeter. That's just 2/3 of that of aluminium. 6 times the specific stiffness of steel. It is non-magnetic, high melting. It has a high melting point of 1287 degrees Celsius. The disadvantages are its toxic dust. It is brittleness, and it's quite expensive. This is a picture from the great James Webb Space Telescope. Its mirrors are made of beryllium, and they are plated with gold. The beryllium is several advantages. It is very strong, and it can hold its shape across a big range of temperatures. That's a very big advantage of beryllium. That's why it was used. Did you know that each mirror of the James Webb Space Telescope is aligned to 1/10,000th thickness of a human hair? That's very impressive, and that shows you this is a high-tech telescope. This is a picture of beryllium foil. It can be used for vacuum windows because it is transparent for X-rays. And this is a picture of a vacuum window of an X-ray microscope. This at the left is how you can use beryllium in the neutron cancer therapy. Here, this is a dummy head. It is used for calibration of this machine. And at the right, you can see the beryllium target, which is water cooled. The beryllium is hit with a beam of protons, and then it produces the neutrons, and the neutrons are used for the cancer therapy. This is the alloy of beryllium and copper, which can be used to make pliers. Typically, the copper alloy contains half to 3% beryllium, and its advantage is its tensile strength. It's non-sparking. That's very important for environments that are critical for explosions. This alloy is also non-magnetic and very corrosion resistant. And that's why this alloy is also used as leads for pacemakers. You want a part that has a long life. And pacemaker is a long life device, and that's why this alloy is used for this product. Novaflex is another beryllium alloy. It's used as a mainspring in watches. The reason is its low thermal expansion coefficient. And Novaflex is an alloy of cobalt, nickel, chromium, iron, tungsten, molybdenum, titanium, and beryllium. This is a picture of beryllium oxide. It's also called beryllia, BeO. Can be used for ceramics as a refractory material, for semiconductors, and for rocket engines. And again, you have to avoid it as a powder, because the powder is carcinogenic. When it's sintered, then it's safer to handle. At the bottom, these are the reactions how you can make beryllium oxide. One way is by roasting beryllium carbonate, using beryllium oxide plus carbon dioxide, or by dehydrating beryllium hydroxide to beryllium oxide and water. This is one other advantage of beryllium oxide. It's high thermal conductivity. That's why it's used for thermal management of lasers, and one application is in eye surgery. This is a picture of beryllium sulfate tetrahydrate, BeOH2SO4. The X-ray crystallography showed that the beryllium connects to 4 water molecules, beryllium ion. And that's very interesting because the beryllium is small. It can just connect to 4 water molecules. For comparison, magnesium sulfate exists as a hexahydrate and connect to 6 water molecules. This is a picture of a beautiful emerald. It's a gemstone variety of beryllium aluminum silicate, and its green color comes from 2% chromium-3 ions. That was today's video about the chemical element beryllium. Thank you for watching. Have a nice day. Bye-bye.